Thank you all for coming here. My name is Sofia Bobadilla. I'm presenting today the work I have done with the professors Richard Glassy, Alexander Verheul, and Monty Morperus. And before starting, I just wanted to thank the Eclipse Foundation for accepting our talk on this conference. So before starting, I wanted to introduce myself. As I said, my name is Sofia, and currently I'm a computer science student at the University of Chile. And last year, between between October and June this year, I was doing a research internship in the Royal Institute of Technology. So in case you have any doubts, here is a picture of me buried in the snow. And this matters to you because what I'm going to present today is what we actually did during that research internship, which is SOBO. So SOBO is an automatic feedback tool that nudges code quality practices on students. And what we're going to talk today is mostly to walk you through the whole process of designing the bot, implementing the bot, collecting results, to summarize what we actually learned from it. So before we start, I need you to put you in the context. So let's take a travel time machine, and let's go back to your first computer science course. So I guess it depends on how long ago did you have this course, but currently, this course looks a bit like this. So it's a huge room with, I would say, 100 students. It's already part of the first year of engineering degree, no matter which engineer is it. And some students feel like half of them know what they're doing, some of them have experience, some of them not. Someone is with a computer, or someone's just with their notebook. And suddenly, someone starts mentioning, OK, we are going to work on this idea, and or you have all these options. And then someone comes and says, OK, what we are going to talk during this course is OOP, and you hear abstraction and some other topics. And then there is a very friendly, not so friendly hello world in a CFD that you might have might never use that functionality in your computer, and students end up like this. So under what I try to recreate is the first class. But during this course, almost 2/3 of the whole semester looks like this. And under these circumstances, yes. So it happens that students feel overwhelmed. It happens that there is so much information to work through the course that they can only grasp a tiny idea of what you have. So said this is like a note, like something about I have to study, maybe I should do the homework the day before the deadline. And it's really hard for them to actually get the point. And what usually happens is that in a room that big, it's just one professor, just 5-10 TAs at max. And if you're not careful with giving the proper instructions, your email looks something like that. And this matters because today we're going to talk about feedback on computer science education. So we collect some experience, we analyzed, we read the literature about it. And the summarize is that feedback on computer science education has 3 main problems. So the first of all is that it's really time-consuming. And on an introductory course, it's even harder because you struggle with the problem that the code might not even compile, and you still need to get feedback about it. So first, the step number 1 in that case is to fix it. Try to understand what the student did, and then to try to suggest them how to fix it, maybe try not to give the right answer. The second problem is that there is a lack of human resources, so it's a big bunch of students and just a few people in the teaching staff. And the third problem is that if you don't give the proper feedback, they will go and try to look their own. And there we have already several versions of Python, for example, and if they want to find a solution to something, they might find a Stack Overflow from 2014 that says something that today it won't work. So they can get to inadequate source of information, and they don't have the ability to judge if it's correct or not. And so because of these problems, and because in computer science we are really handy people, we love making our tools, is how bots can help for education. So a bot is a robot that runs on code. And how this can help is, so we have here, like I said, to actually give feedback on a computer science course, you need to go through a few steps. And what happens is that it takes time. So bots can help by making this automatically, maybe not to give the final answer, but they can actually comment on a few things on the student code. So for example, they can comment on syntax errors, or they can comment on code quality, or they can comment on test base. And I would like to show you some examples. So for example, in the Technical University of Munich, there is a bot called Artemis. So what this bot does is that they present a software to the students where they can actually upload their code, and in a very friendly way, it says it's a test-based tool. So they have, you can say like there is, for example, a task per week, and for each task there is a pre-setup on the software, and it walks them through what tests are failing and how they can fix it. So if we see it on a like I say, in a product competition way, the students either have this, or they have a compiler that has a bunch of red code that they cannot understand at all. And another example is Tafis, which is a requirement-based tool. So it's a bit less graphic than the other one, but it tried to explain them, OK, this is your requirement that you were supposed to fulfill, and this if it fulfills it or not. And at the same time, it also brings them, like, it gives them the mark of their each requirement. And OK, so this is automatic feedback on how they run their code, or it also mentions about the marks. But in our project, we were thinking about, OK, we have all this information about how their task runs, if they're doing what we actually ask them to do, so for example, with the requirements. But we found that in KTH, we have a teaching staff for this course. And we were commenting once, we noticed that the students actually have a really messy code. And by messy, we mean they are not using the right names. It makes it even harder to assess. So we tried to find something that could actually help for us on this topic. And we did not find like a proper tool for this. And then our teacher, Richard, said, like, OK, but is it actually a problem? Like, is a student's code quality on introductory courses something that we should actually care about? So a recent study analyzed the historical data for a course. So they have around 19 tasks during a whole academic year, and the course repeats itself for 6 to 7 years almost. And what they found is that there is not a common pattern during the whole academic year. So it doesn't mean that they get reduced on code violations. They just keep existing there. And why they still have code quality violations through the whole course is because they are not aware of it. So if they are not aware that they are doing something wrong, that they are choosing the wrong names, then they just keep doing the same mistakes. And they are not being aware of it because the feedback that they are receiving is mainly about how to make their task compile and not how to actually make them correctly. And that's why we create SOBO. So again, SOBO is a feedback bot to nudge code quality in programming courses. And I would like to emphasize that it's a nudge bot. So our main goal is to try to lead them into being aware that they have to choose the right name, that they have to do it properly, and not necessarily to completely change their behavior. So if we put it on a phrase, SOBO provides automatic feedback only related to code quality on programming courses that uses Java as programming language and GitHub as a control version system. And the workflow of SOBO is that a student is working on a GitHub repository, and SOBO constantly looks at that repository. So the first functionality is automatic feedback, the main one. So the students produce commits, and SOBO keeps looking at these commits. It analyzes through static analysis tool, in this case is SonarSource, and then it fills some templates that we have prepared for them, and then updates on delivery channel that we decide. And on the other side, students can also communicate with the bot. So we have a comment panel where they can actually send the interactions they want. So for example, provide the service, stop the service, and so on. And SOBO will try to reply out as soon as possible if it can actually understand the comment. So I will going to explain how we designed SOBO and how actually it looks. So first, I would like to clarify that SOBO has its own account. So when SOBO sends the feedback, it's not a person who is behind the bot, it's the bot itself. So we create a GitHub account for SOBO in KTH Enterprise GitHub, but there is also a SOBO on normal GitHub. And it's a very friendly bot, so it says, hi, my name is SOBO, and tries to be like really playful. And this is his README on GitHub, so it says what commands it can understand and how to reach it. And when SOBO actually acts, looks something like this. So this is the student repository. So in this case, the student is SoftBob. And SOBO opens 2 issues to communicate or to provide the information. So the first one is the commit analyzer, and the second one is the command issue. And in terms of the commit analyzers, which means the automatic feedback, it sends them a message. So, hi user, I found this. This is how I can fix it. I will explain a bit more about the feedback itself later. And yeah, so it gives a big comment, and the student can actually see it. As you can see, it says that who made it is the bot. And then we have the command issue when the student can actually interact. So SOBO open the issue and give them all the commands that it can actually understand. And then the student interacts with the bot. So here is an interaction of them. And as you can see, here is the student, and here is the bot. So how we design the bot? So first, as code quality measure, we said we are not going to redefine what code quality is. We are just going to use something that was already existing. So we choose SonarSource rules, but in SonarSource, we have 662 rules, and they are not all applicable for a programming course. So we actually make a filter. So we curate all the rules based on 3 main factors. So first, that is actionable. So it's something that they can fix with not too much effort. So maybe changing a line, changing the order, changing a name, or deleting a line. That it's between in the knowledge gap. So is there something that they can actually understand? And third, that is an actual problem. So I showed you a study before when they analyze students' code quality. So they have a ranking between which one were the most violated rules. So we also took this in consideration. So it's a rule that they will actually make through the course. And here's an example. So this is the most famous rule that the students do during the semester. So it's magic rule. So it means that you are using a number. Sorry, it's a magic number. It means that you are using a number that you are not defining before. And this only works if the number is not 0, -1, or 1. And what it tells you to do is that you should actually define the variable, and if it doesn't change, it should be like a final, and that you should define it at the top of the class. Another one that we use, and the second most famous rule, is unused local variables. So it means to remove something that they're not using. And this one in particular, as TAs, we really were extremely thankful because they understood that, hey, if I'm not using this, I should just remove it from my code. And they actually started making way more clean code than before. And as a distribution channel, so this means how we actually connect with the students, how we send the feedback, we choose GitHub issue tracker. And why we decide this? First, because the students already work on GitHub. They already get their grade on GitHub. So we say we don't want them to go to their email. We don't want them to go to a web page. We just want them to get the information right there to lower the effort barrier. So why we choose this? Because it's in one stack, because there are less notifications, and because it's a direct channel with them. And that's why when I'm talking about distribution channel, this is what I meant, what I showed you before, that when you have your repository, you have two main issues to interact with the bot. So functionalities, I already showed you this overview before, but again, on the purple side, we have the automatic feedback functionality. On the orange one, we have the command interaction. So first, the automatic feedback functionality. So what we do is that we provide feedback about a rule violation, but just the most popular one on the rule. Why? Because, as I mentioned, we only want to nudge them into changing their behavior. We don't want them to actually submit the tasks with no code violations. That would be our dream, but as long as they work on one, we are OK with it. So that's why we say, OK, we are just going to analyze the whole report from the static analysis tool, and we are just going to pick the one that is more popular. And when we provide this feedback, what we make sure is that we give that our message contains three main parts. So first, we explain, I found rule X. This is the rule. This is what it means. This is where it is. So we don't want them to see, OK, this is how the rule works, but where in my code is it? No, we just want them to be very actionable. So they can actually click on a link, and they will send them to the file when they are having the violation. And as example, so this is what this is how you are not supposed to do it, and this is how you are supposed to do it. So they can actually look at the example and fix it. And the third part is extremely related with the rule selection, when I mentioned that it was actionable. So our idea is that they can see these three parts, and especially with the example, they can go directly to their code and fix it. And the feedback itself looks like this. So we have here I show a header and table. So here we have the rule. Here we have the location. And then here we have the example. So instead of doing this, do this. And as I said, so it's a very friendly bot. So it tries to interact with them in a, I don't know, like giving Easter eggs or similar. And the second functionality is the command interaction functionality, when they can actually talk with the bot. So this feature allows them to actually stop or restart the bot. So that was essential. We follow a previous study that provides guidelines for bots on GitHub. And they say it's essential that your user can actually stop the service. Why? Because if they are forced to see, maybe that has happened to you, you have lint on your ID, or you have a common code smell on your code, and your ID keeps telling you, fix this, fix this, fix this. And then at the end, you hate that rule. So what we don't want them is to see SOBO as something negative. So if they get tired of the bot, they can actually stop it. And they can ask for more information if they want to, and they can also like interact, so that we wanted to use it also to increase engaging with the bot. So I showed you this picture before, so it looks like this. This is the issue that SOBO opened. It gives them the commands that they can use, and here's how they can interact. So they comment on the issue, and then SOBO replies. So now I would like you to show you how it works. As you can see, it's very to-the-point bot. So here I have SOBO monitoring my GitHub repository. Oh, sorry. Thank you for telling me. Duplicate. Can you see it now? Yes. So as I mentioned, SOBO, it's monitoring at a GitHub repository. So here I give my repository, which is called Sofia Bobadilla /task2. So here I have the instructions. So I download the template, and I work on it, and then I submit my task. So I say, OK, let's see what I have here. So here is the commit analyzer, and it says, hi, Sofia. You post a new commit, give out the hard work, so very encouraging. And this is the violation you have, magic numbers. I don't know if it's too small. Maybe we can make it bigger. And here it gives me the link where I can actually find the file when I'm having the violation. So here is file path, line 3. So I'm coming here, and Here's the problem. And why is it a problem? Because I'm using 6 here, 5 here, and 2 here. And here we have another one. In the source folder, I have dice, and on line 8, again, I'm using this one. So then I look at the whole message, and it says, magic numbers are numbers that are used in your code without any explanation. This can lead to confusion and bugs. Here is an example. So instead of, oh yeah?
May I ask a question?
Yes.
Is it possible for instructor to add extra feedback to the messages?
Yes. Like to change this template?
No, by adding some extra feedback to a certain rule violation.
Yes. So now we configure the bot with 6 rules, but if you want, you can add more. Or you can actually use another static analyzer too. So here we have, OK, this is what I showed you before. This is what you shouldn't do, and this is what you should do it. And so if I were to fix it, for example, let's try to fix this one. Oops, I need to be on the branch. CRC, dice.java, and I need to fix line 6. So I'm going to make here variable protected int dice size equals 6. And then here, instead of just using 6, I'm going to use dice size. So now I would like to commit my changes. So I'm a very good student, so I use conventional commits. So fix SOBO violation on file dice.java line 8. And then I commit my change. And I should wait a bit until SOBO receives the commit. Let's see if that's appear. OK, so it's appeared that I commit. And let's rephrase. It was edited just now. OK, I didn't fix it. I wonder why. Let me take a second look here. Protected in dice size. Oh, so it says, yes. So as shown in the commit analyzer, I should define the variables as final if I'm not going to change it. So I didn't read the whole message. So now I can fix it. Fix on dice.java. Here I'm committing the changes. And as you can see, it didn't create a new issue. It only updates the body of the issue itself. So why we choose this? Because it doesn't send you another email regarding the issue itself. So what the students can rely on is that on this issue in particular, the commit analyzer, they will always find the last run of the bot on their commit. So I did here, and as you can see, it says, OK, it disappeared. So now I can only have to fix bias dice.java on line 3. And for the command issue, so here I have the bot, and I would like to maybe ask for the commands again. So I will do something like help to remind myself, oh, what commands can SOBO actually understand? And SOBO immediately replies, here's my command list. So what if I want to stop the service? SOBO will say, let's wait a second. OK, he or she, they, will not generate more automatic responses, but I can do it again if I use Go. So let's restart the service. And I just do Go. And when I say we increase engaging, we have some ways that they can actually interact with the bot. So what, for example, if I try to send a code injection? SOBO tries to fake in SQL attack. So let's go back to the presentation. No, I want to start from here. Yes. So we did an experiment on the course at KDH. And we had one repo per task during the whole academic year with 1 task per student, around 130 students, and SOBO was active on 1,600 repositories. And our results, so we did both qualitative and quantitative analysis. So first we asked the students, okay, how do you feel about the bot? First we asked about how concise and clear was the explanation and the example. And most of them were actually neutral about it. Some of them find it not super clear. But our takeaway is that either they agree or respond neutral to it. Then we asked them, was it actually helpful? And again, neutral or agrees with the statement. And then we have, and this was very important for us, how do you feel about having similar bots like this on other courses, on or your own GitHub repositories? And again, most of them agree or are neutral about it. In terms of quantitative results, we study the introduced and fixed violations. So how many they commit one and how many they try to fix one. And as you can see, we have way more introduced violations. And we thought this is OK. I mean, currently, or the history of the course shows that they actually do it. But what it matters to us is that at least some of them were trying to fix it. So they actually did some active actions to do it. So there are some fun results that we couldn't add on the paper that I would like to share with you. So first, we followed 3 students' progress that at the beginning they actually liked the bot and they tried to use it. And especially with magic numbers, for the rest of the course, after task 3 or 4, they never make the same violation again. So they always submit the task while defining the variables. There was only 1 student who tried to stop the bot. What I show you the code injection is because actually 1 student tried to send several SQL injections through the command interaction. So we say, OK, we really want them to play with it. So we create a honeypot on the command. And we found at least 25 commits that were that on the message it says, I'm fixing a SOBO violation. So for us, it was a clear signal that they were actually acting based on the bot. So our takeaway from this experiment is that we have enough information to assume that SOBO helped, or at least nudge them into adopting these code quality practices, that we have some glimpse of interactions with the bot, like I mentioned on the message, or because of the violations that were actually fixed. And we consider that choosing the right channel, in this case, the GitHub issue tracker, was the key of SOBO success. So it's not something that they needed to go and look for in another web page in their email. It's something that was right there in case they need it. And so how can you use SOBO if you're interested? You need first to create your own SOBO account, because we don't want to, we know that getting access to GitHub Enterprise in your own university is a struggle. So if someone wants to use it, they need to create their own GitHub account. They need to prepare the database for SOBO to run on it, and to configure the file. And you can find the instructions here on the repronator GitHub rate. But indeed, we would love if someone wants to use SOBO, but our main our main task for today is not to actually sell you the bot or ask you, yeah, you can use it, or we will love it if you use it. But what we really want you to learn from today is that first, that if we want to create an effective bot, we must look at the final users. So how to actually make them use the bot, how to make them easy, how to lower the configure barrier. To also understand that, OK, so I have get some comments that, yeah, but I can just use a good IDE and install a plugin that actually help me with code smells. Yeah, we can do this because we are experienced developers. But in that first course, in an introductory course, there are 6 months of real struggle when they cannot actually, when having a complex IDE or having a complex plugin actually makes more damage than help. So even though SOBO can only exist in a student environment for 6 months, it's still worth it to use it. And it still helps them. So we consider that our efforts is not worthless because we have at least one generation of students at KTH who are aware of code quality when programming. So we would like to consider that we are trying to attack the code quality problem in the developer world since the first moment. And finally, that we are preparing the programmers of the future, so we consider that any effort made or spent on this, it's actually valuable. And before I finish, I just wanted to mention we have a focus group when we were starting this project. And there was one student, he was actually from Italy, and he said he's not a computer science student, he's an electrical engineer. And he said, I feel like on my first programming course, I was like a horse just trying to compile and submit as soon as possible. But then when I needed to actually use what I learned, I noticed that I learned it in the wrong way. So it's the same as when you're learning a second language. You shouldn't translate the thoughts on your main language and then speak, for example, in my case, in English. The idea would be like start from the beginning thinking in the new language. Same with this. We would like them to, from the minute that they are thinking about how to solve a problem, to have code quality on their minds. So thank you for coming today. Yeah. Yes?
I have a question. Have you guys tracked how often a student fixes an error and then moves to the next one, like trying to get it perfectly done?
I mean, like following the same line through the code. No, we didn't manage to do that because they were both fixing violations and working on their task. So it was really hard to compare the lines of rules that were actually part of a new feature of the task or actually something that they were trying to fix. Yeah. Yes?
Have you checked if you eventually need to improve your rules now based on what the students do? So for instance, from own experience, I know that a lot of developers would fix the magic number by introducing a static final variable called FOUR equals 4 instead of number of cycles or whatever. And this is a pattern that I have seen so often. I would expect that this is now the new magic number problem.
Yeah. So we were thinking about adding rules according to their knowledge progress. So for now, we just choose these 3 main rules. But the idea now is that we run the both since the first task. And then on task 5, we add the consequences of the first ones. Yeah. Mm-hmm.
It's not the learning part. The bot doesn't learn about the mistakes the students make and chooses the feedback.
No, we did not. That's part of the iteration too. And actually, I don't know if you saw that on when I showed the results, there were some red students that were like, I didn't like the bot. So the person who said like, I don't find the example like useful, they keep trying to fix magic numbers over and over again. And then they wrote like, I have no idea what magic numbers is. I just know that I hate it and that I don't want to see SOBO anymore. So we actually would like to have this track to rephrase the explanation. So now we have only one template per rule, but we would like to explain it in a different way. So yeah, that's part of iteration too.
Explanation is exactly what I was going to ask about. Do you think the students learn to be obedient programmers that just have learned some rules, thou must do this, thou must do that? Or do they understand what's wrong with a magic number? Or can you even take maybe this back into the actual class and talk about the reasons behind the rules? Is that the understand what's wrong with the magic number?
I see. So you mean like if they just change in the commit and they wait for the bot response until it disappears, right? If they were doing that. No?
Do they understand why they should follow this rule?
Oh, okay. So that was a task that was assigned to the teacher assistants, and some of us commented during the exercise classes. Some of them sort of understood what was the problem, the ones who were more interested, but not all of them.
Is the project still under active development? Are you still continuing with the project?
So we wanted to, I'm back in Chile this year and I wanted to run it there, and the problem is that the students are not using GitHub or in first course. But I'm going back to Sweden next year, and we really want to do a second iteration of SOBO. So this year they are without the bot, and we are going to analyze how are the violations in both of them. And according to that, we are going to keep running the bot. Yeah, the teacher was, so the teacher didn't have to do any effort to run the bot. The bot was just there. It didn't even need a TA to, I just needed to play run and run through the whole semester. So it didn't add any teaching load on the course. Yeah, so if everyone is interested about reading our project, we have a submitted paper on IEEE, and here is the link if someone wants to read it. Yeah, I don't know if we can have more questions or... Yeah? No?
SOBO or software bot or Sofia bot?
No, it's named after me, but I didn't want to name it for my name. Just that my boss is French. So when he thought SOBO, I said SOBO, but he's like, SOBO! And it sounds so cute that they say, OK, let's keep it. Yeah. Thank you.